Concept 30, Part 1, the counting principle, probability, and odds. First, let's start with some vocabulary, definitions, and formulas. Let's talk about sample space. So sample space is just simply the number of ways that something can occur. So one way to show how many ways something can occur is to use a tree diagram. A tree diagram is a ways to organize combinations of an event. Now look down into the notes section and let's look at number 1. So how many different ways can you order an ice cream cone if you have 2 choices of cones, waffle and sugar, and 4 flavors of ice cream, chocolate, vanilla, strawberry, and mint? Well, you can organize this by creating a tree diagram. And so draw this in your note space on your notes handout. So first we simply write down 2 of our choices, and we'll just start with our choice for cones. We've got a sugar cone and a waffle cone. And then what we do is we just use branches to show from each of those choices how we could combine them with our choices of ice cream. So off of our sugar cone we do a branch for chocolate and one for vanilla and strawberry and mint. And then off of our waffle cone we have those same choices: chocolate, vanilla, strawberry, and mint. So what this first one represents is if we have a sugar cone, that's chocolate. This one is a sugar cone with vanilla. This is a sugar cone with strawberry, sugar cone with mint. You get the idea. So to figure out how many different ways we can have our ice cream cone, we simply can count up these choices here, and that equals 8. So there are 8 different ways that we could have an ice cream cone where we have 2 choices of cones and 4 choices of ice cream. Now, besides using a tree diagram, there's another way to figure out our sample space, which is the number of ways that an event can occur, and that's by using what we call the counting principle. So up in your vocabulary definitions section, the counting principle is simply ways to count an event by multiplying your choices together. So you're going to multiply your choices. So if we think about the ice cream situation, we have 2 choices for cones, and we have our second choice is for ice cream. We have 4 different flavors for that. So if we simply take 2 times 4, that will give us 8, which is the same answer that we got when we used the tree diagram. So what's called the counting principle is when you multiply together just the amount of possibilities that you have for each of your choices in an event. Now look down into your notes section and let's look at number 2. So we're buying a new car. We've got some choices to make with this. We have 2 body styles to choose from, 5 colors that are available, and 3 models. So our question is, how many different choices or combinations can we make with this new car? So here it is in a tree diagram, and you can just look at this. So you can see that we've got, first of all, the 2 different body styles of car here and there, and then connected to those we have branches for each of the colors, and then from each of the colors we've got branches for that final choice. And so if we were to count up these, that would tell us how many different ways we could have our new car. A simpler way to do it is by using the counting principle. So for our body styles, and this is what you can write now, number 2, because number 2 says how many choices for a new car do you have if you choose 2 body styles, 5 colors, and 3 different models if you choose from those. So we have 2 times 5 for our colors times 3. So 10 times 3 is 30. And in our tree diagram, if we had counted up all those different ends of the branches, we would have seen that there are 30 different ways that we could order a new car. Now let's practice using the counting principle and finding sample space, which you know is the number of ways something can happen, or the number of possible outcomes. So example 3 says find the sample space when rolling a die and flipping a coin. So when you have a die, you've got, so here's my blank for my die, we have 6 different possibilities that occur. When flipping a coin, we have 2. So if we multiply those choices together, we get that there are 12 different ways for that event to occur. Example 4, we're making a sandwich. We have 8 different choices, this is like Subway, for bread. We've got 5 for meat, and 10 for our veggies. So we can multiply those choices together and see that altogether there are 400 different ways that we could order our sandwich. All right, now we're going to talk about probability. So go back up to your vocabulary definitions and formulas section and find where it says simple probability. Simple probability is just your chances that something will occur. And so the way that you figure those is that you take the number of favorable outcomes compared to or divided by the total number of possible outcomes. We can express probability as a ratio, a decimal, or a percent, and we're going to practice all 3 of those. When you talk about probability as a ratio or decimal, all of those, the probability will fall between 0 and 1. It could be 0 and 1 too. If the probability of something that occurs is 0, that means it's impossible. If it's a 1, that means it's 100% certain that it will happen. And then we can just go in between. So 0.5, that's like a 50% chance. That's likely. If it's 0.25, 25% chance, probably unlikely, but maybe. And then if it's a 0.75, likely that it may happen, but it may not. And so that's if you talk about probability as a ratio or as a decimal. Let's figure some probabilities. So look at example 5. You have a bag of 5 green marbles, 3 red marbles, 4 blue, and 8 black. Find the probability that you will choose a green marble when you draw one out of the bag. So remember, probability is favorable compared to total. So right now our favorable is the green marbles, and we have 5 of those. Our total is 5 plus 3, which is 8, plus 4 is 12, plus 8, so we have 20 total marbles in the bag. So we compare that to 20. We can reduce that and show it as a ratio. So it's 1/4. We can divide that out and get a decimal. So our probability is 0.25 or 25 hundredths. And then finally we can move our decimal 2 places to the right and show that as a percent. So it's unlikely, but we may pick a green marble. Now let's look and find the probability that you'll choose a red marble. So red is our favorable now. So there's 3 of those compared to 20. That ratio is reduced. If we divide that out and write it as a decimal to 2 places, it's 0.15, and then move that decimal place 2 places to the right, we have a 15% chance that we're going to choose a red marble. Now let's talk about finding odds. Odds are a little bit different than probability because what you're doing is you're comparing the favorable outcomes, what you're looking for, to not the total. You're comparing them or dividing them. So actually we're just comparing them to the unfavorable, what we're not looking for. And so odds are expressed as a ratio. So let's try that on your note sheet. You have 5 triangles and 3 circles. What are the odds of getting a triangle? So now a triangle is our favorable, and there's 5 of those. And we're going to write using a colon for a ratio. And then the odds of getting those, the unfavorable would be circles. So triangles compared to circles. So the odds of getting a triangle are 5 to 3. Now the odds of getting a circle, so circles are favorable. So we list that first, and we compare it to our other choices, which is triangles, 3 to 5. If we could reduce that as a fraction, we would, but that is in lowest terms. Let's try the next one. In a contest, 5,000 enter, but only one will win. What are the odds of winning? So we're looking at that one, so that's our favorable, and then all those that would not win would be 4,999. So our odds are 1 to 4,999 of winning. That concludes part 1. Now let's look at part 2. We're going to figure the probability of compound events. So on your note sheet, go to your vocabulary, definitions, and formulas. Under compound probability, you can get this definition down. The compound probability is the likelihood that 2 or more events will occur, whereas simple probability, we're just looking at one event. There are 2 types of compound probability. The first type that we're going to look at is probability that happens in an or situation. And as you read the situation, you will actually see the word or. So on your note sheet, you can now look where it says compound probability with events that say or. So you roll a number die. What is the probability that you will roll a 3 or an even number? So the first thing you want to ask yourself are the outcomes mutually exclusive or overlapping? So mutually exclusive means that those will not occur at the same time. If they're overlapping, that means they can occur at the same time. So mutually exclusive is they won't occur together. Overlapping is that they can occur together. So I have listed out that you roll, first of all, just how many 3s. So this is the chance of rolling a 3. And then I've listed out the even numbers. So on your note sheet, let's figure this probability. So the chances that we will roll a 3 are 1 in 6. There we go. And then when you see or, we're going to add those probabilities. The chances that we'll get an even number is 3 and 6. Now these are mutually exclusive because we can see that none of these, either a 3 or our even numbers, overlap. So we simply add those probabilities, 4 out of 6 chances. We reduce the fraction 2/3, and then we can write that as a decimal, which is 0.67, or a percent, 67%. Now go back to your vocabulary definitions and formulas, and let's get down a formula for if we are figuring compound events that are mutually exclusive. So to find the probability of A or B happening, you take the probability of A, so this was like the probability of rolling a 3, and you add it to the probability of what we can just call event B. And that we could think of as the probability of rolling an even number. Now let's figure another compound probability situation that also asks us for one probability or the other. So you roll a number cube, and you say, what's the probability that you roll an odd or a prime number? So let's list out those possibilities. Here are our odd numbers, and then here are the prime numbers. And then we look and see, are they mutually exclusive, so that neither event can occur together, or are they overlapping? We can see that we've got 2 that are overlapping. So in that case, we first of all figure the probability of our first event, which is odd. So we have 3 out of 6. We add it to the probability of the second event, prime numbers, which are 3. And then we need to subtract off the ones that are both odd and prime. So we subtract 2 out of 6. So we get 3 plus 3, which is 6, minus 2, which is 4, 6. And we reduce that to 2/3, just like the other one, we can write it as 0.67 or 67%.